Hello, hi Fortuner. Yo ho. How are you doing? I saw your little falling out on Discord. Is everything okay? I feel like you're always getting in trouble online. Alright, I'm just setting up Leetcode on my end. That's what I do in the starting streams. Isn't Subteralia not a thing anymore? What are you talking about? Wait, did I read it wrong? Did that not happen? No, wait, Subtermonica. That's what it is. Subtermonica's not a thing anymore, right? Yeah. Pew. Yeah, it's F forever. No. My one chance to be in a game. Well, it sucks to start a project and not finish it too, so rip on your end too. Fortune says, but don't worry, I will try to revive it. Oh, that's exciting. I wonder what... Are you still going to use Subtermonica? Or are you going to do a different Subter now? Also, I'll be right back. I'm going to get some water. Oh, I'm back. Water. Fortune says, check Discord, I sent something. Ooh, what did you send me? Does this look like Windows 7? Oh my gosh, it does. Another thing you installed. Man, this... It says on the bottom right, Windows 11 Pro Insider Preview. You can't fool me. That brings back memories though. I do remember owning a Well, my parents owned a laptop that ran Windows 7. Oh dude, you have Unity installed. It's pretty cool. Are you learning how to use Unity? And Krita, let's go Krita. Yeah, my parents used to own a Windows 7 laptop. Hey, people are right. It does look like liquid glass on the iPhone. They were ahead of their times. It even has the startup sound of Windows 2000. Dang. I remember my parents used to have this really boxy beige computer that ran Windows XP. It ran... My brother and I used to play Road Rash and some weird humanoid chess game where the pieces came alive and you could attack with each other. It was actually kind of gruesome. Thank goodness it was so pixelized. Like, when the king attacked, for example, another piece, he would literally dismember him, chop him up, limb by limb. I know my way around with Windows. Yep, I can see that. Well, you're called Windows God and Fortuner God. Do you know a way around Fortuners too? Anyways, I'm gonna pop in here. Hello, good evening. It's evening in my time. It's probably afternoon for you, Fortuner. Hello, hello. I'm gonna be honest. For this particular problem, I looked up the dynamic programming solution because I was so intimidated by it. I had enough trouble with the last dynamic programming solution. I looked at the solution and I don't think I still understand it. But it's okay, we'll take our time with this one. I want to try solving this with recursion first and then we'll go to dynamic programming. We're probably going to spend all stream on this one problem. Fortuner says, yep, Fortuner God. I even know how to tune it so it makes it 500 HP. Wait, that's so cool. You know how to tune a car? You know your way around cars too. You're like a mechanic. Okay, this problem. Longest increasing subsequence given an integer array nums, return the length of the longest strictly increasing subsequence. Subsequence being basically you have to preserve the order, but you can delete elements. Is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So, for example, you can do Fortune says, yes, yep, I have ADHD, so if I wanted to, I could learn how to make a rocket ship as well. Ooh. Dang, you're good at learning stuff. I wish I was good at learning stuff as you too. I am struggling to learn DP currently. Okay, so basically the problem is given an array, return like a sequence of numbers that appears in order in this array. You can delete elements if you want. That forms the longest strictly increasing subsequence. So for example, you can be like 2, 5, 7, maybe 18. These are all in the same order. Yeah, you can skip elements there, but they're in this. The bottom line is they're in the same order in the array. So you can return this as an answer. This would be 4. The longest increasing subsequence is 237 101. Therefore, the length is 4. Oh yeah, there could be multiple solutions per array too. Like this forms 4, 237101 forms 4. Also, is my PC specs good for VTuber Studio? I have no idea. I've never used VTuber Studio. I use VC Face. And even if you tell me your PC specs, I probably wouldn't be able to tell you if your PC specs are good enough. I don't know computers that well. You probably gotta ask someone else for that. Or Google it, ChatGPT it. Okay, what does the recursion for this look like? In our function, we have our nums. Fortune says, dang. Yeah, I'm sorry. I'm not good with PC specs. My current computer build, I basically asked a friend who worked in hardware to recommend parts given my needs and budget. And then he did that. And that's my current PC. Yeah, my friend works in... Basically, his job is to ensure that particular software runs as fast as possible, given that he can manipulate the hardware. Yeah, so he's like the perfect person to ask for PC parts. Oh, I spilled my water a little. Give me a moment while I pipe this boy up. Okay. So ooh. Am I so sleep deprived? I can barely talk right now. My tongue is doing gymnastics in my mouth. Okay. Recursion function. So obviously we're given the nums. And what do we need to track for this recursion? We probably need to track the current index, right? The plan should be to iterate from maybe left to right in the array. And then at each number, we have two choices, right? We either use a number or don't use a number because it's a subsequence, right? You could either delete or omit a number from the subsequence, or you can include it in the subsequence. So we probably need to track I to track which number we're iterating on. We also probably need to track the previous number. Should this be the I? Maybe for consistency, I'll track the previous index. Basically the index of the previous number that we've included in the subsequence. So we can be like, okay, is the current number strictly bigger than the previous number? That's the purpose of tracking that. What's the base case? So if I is out of bounds, oob, then we return the length. So we return 1, I guess. No, we return 0. So then we can begin counting. The previous recursive frames can add 1 to this and begin counting length. Fortune says, well, I just came by to drop by. See ya. Yep. I appreciate you stopping by. Okay, what's the recursive calls? So there's two choices, right? One is we use the current number that I is on. So we can do like 1 plus f of the same nums, I plus 1. The previous I becomes the current index. That. Yeah, and we can only do this option if we're strictly greater than the previous one. Else we probably have to make the bogus answer like negative infinity or something. The other option is to skip the current number that I is currently on. So we'll do f of nums is the same, I plus 1 is the same actually. we head to the next number, but the previous index stays the same. So the goal is to return the length of the longest strictly increasing subsequence. So the answer is the max of either one of these. Yeah, that's the solution, right? Is there a base case I haven't taken care of? I is out of bounds, return 0. Yeah, what else are we gonna do, right? If we're at a inbounds, we do this. If we're out of bounds, return 0. Yeah, I feel like this is a recursive solution, no? Okay, let's implement. Pointer is here, okay. So we need a helper function. I'm gonna duplicate this because the function signature is gonna be kind of similar. I'm gonna call this helper. We need a nums. We also need I, which is a int, and then previous I, which is also an int. Cool. Okay, so in this helper function, if I is greater than or equal to length of nums, then you return 0, so the previous recursive frames can start adding up stuff. And also, you know, the greatest subsequence starting at an I that is out of bounds is just 0 logically, I guess. Okay, so after this, if we aren't at our base case, we have to do our recursive calls. I'm going to call this the best result of using me. Use me is equal to, so the goal is to return the length of the longest one, right? So let's instantiate this to float negative infinity as a bogus value first. So we can only use me as in the current number, if the current nums I is strictly greater than nums the previous I. And then the cost or best result from using me is equal to helper nums I plus 1 with the previous index being I. And then else, the best result from not using me, no use me, is equal to helper nums I plus 1. Previous index is the same. Previous index. And in the end, you return the max of use me or no use me. Up here, you call your helper function helper nums I starts at 0. Previous I. Oh, what is the previous I? -1. Sure. I guess that's our bogus value. Previous I. Where do we use previous I? So if previous I is equal to -1, our bogus value, meaning we haven't used any previous value yet, or the current number is bigger than the previously used number. Okay, I think that makes sense. Let's try running this. Helper is not defined. Oh. Self.helper. I keep forgetting that Python requires you to do self.something to pass in the self argument. Use me, also the self.helper. Self.helper. Uh-oh, what happened here? Return max of use me or no use me. Why is my output null? Also, I just realized use me. I should be adding 1 to using me, right? To actually count the number that I'm using. I don't think that will explain why we're getting null though. Output is null. Oh, why is that happening? Float negative infinity. Is this considered null? Use me. No use me is equal to self.helper. If previous I is equal to -1, meaning there was no previous, then you can do this. Or nums I greater than nums previous I. Okay. No use me is equal to self.helper. Nums C of tranquility says hi. Hello. How you doing? Hello, C. Are you a top or a bottom? Bottom up DP or top down recursion with memoization. Sorry. Anyways, I'm currently doing Leetcode longest increasing subsequence. I'm trying it with recursion first, top down. I plus 1. Sea of Tranquility is like, I don't know why my current recursion is giving me just answer null. So my base case is if I is greater than or equal to the length of nums, like the current index, then return 0. The cost of using me or using my current number that I represents, missing return. Return is here. Oh my gosh, you're a genius. Return. Oh my goodness. Let's go! It worked. Bro, you're a smart dude. Thank you. Though we're probably gonna get time limit exceeded on this one because Python sucks with recursion frames. Opening up recursion frames is supposed to be really expensive in Python. So we're gonna have to turn to dynamic programming for sure next. Yeah, time limit exceeded, yay. It's time to do some DP. Dang, thanks for that save, by the way. I'm so dumb. Alright, who's ready for some DP? It's time to be a bottom. Or try doing bottom up DP. You know what? I'm just gonna duplicate this tab so I can save my recursive answer. Okay. What does dynamic programming look like? Help. I actually don't help. I want to try figuring this out myself. Okay. let's look at whoop, I wanted to make the screen bigger. Oh, there we go. Okay, let's look at this example here. What if we have an array that stored the best subsequence starting at the best subsequence ending at a current number. So this is my array over here. This would be, if we're looking at this example here, the best subsequence ending at 10. That would be, maybe I would instantiate everything with like 1 first. 1, 2, 3, 4, 5, 6, 7, 8. I don't know, I'll just do this, dot, dot, dot. Longest strictly increasing subsequence. Could I do something like, so what's the longest increasing subsequence at 10, ending at 10 specifically? It's 1, right? And then I would go here to 9. And then I'm like, what's the longest increasing subsequence starting at 9? I will look at 10. And like, can I, join 10 and 9 to be a subsequence? Well, 10 isn't strictly increasing. 9 isn't strictly increasing from 10. So that doesn't work. 9 is just 1, I guess. And then we look at 2. Are 9 and 10, is 2 strictly increasing than anything before it? No, it's not. What about 5? Is 5 strictly increasing than anything before it? Nope. What about 3? Oh, 3 is strictly increasing, strictly greater than 2. Wait, the indices are 0, 1, 2, 3, 4, 5, 6, 7. So at index 0, 1, 2, 3, 4, I can do 1 plus the greatest subsequence ending at 2. Ooh. Can I do something like dp of 2? Ooh. 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 And then over here, when I look at 7, I guess I have to iterate, everything before up to the current element, huh? And be like, okay, if any of the element is strictly smaller than me, like 2, 5, 3, I can try doing just 1 plus the best result ending there, and do this for all elements that are less than me, and then take the max of this, And then that's the answer for that specific element. Yeah. Oh my gosh, I'm seeing it. I did take a peek at the DP solution before this, by the way. I didn't understand it though. I think I understand it now. Yeah, so you just want to instantiate a DP array that's the same length as nums. And then the purpose of each element is to store the best solution ending at that specific element. So for every element, you would iterate left to right. And let's say, I don't know, let's say we're on this element. For every element before it, we want to, every element before it, we want to iterate left to right or right to left. I don't think it matters. And see, okay, if that element is less than me strictly, then we can try making a subsequence with me and the best subsequence ending at that particular element. Yeah, so you would do 1 plus max of 1 plus everything that's strictly less than me, dp of that element's index. Yeah, and then in the end, you would return the max, iterate through the array one more time, and then return the max number in the array. Ooh, I think I see it. I see it. How do people think of this? I don't think I would have thought of this if I haven't taken the solution peek in the beginning. Okay. Let's try this then. Sea of Tranquility says there might be an even more efficient solution where you keep the already computed elements in a sorted heap. Oh. Yeah, so instead of iterating for every element behind me, yeah, you would do like, what's the greatest one behind me, I guess? Would you sort by the actual value of the elements? Like, okay, behind 7, 5. Behind 7 would be 5 would be prioritized, and then 3, and then 2. Wait, no, what am I saying? Wait, actually, I'm confused. How would you use the actual value? So behind 7, you would prioritize the ones that are strictly less than me. Oh, I see. So you would sort of smush all the ones that are larger than me in the end, and then prioritize the ones that are smaller than me first. So as soon as you see an element that's, greater than the current number, you're like, okay, I can stop now. That's the reasoning, right? Oh. I see. Yeah, that is more efficient. I think for simplicity, since I'm still pretty new to DP or dynamic programming, I'm gonna try just with a list first. I don't think I even know how priority queues work in Python yet. Maybe I'll try it after I do it the normal way first. Okay, so let's do, we need a int array. How do you do an int array in Python? Oh, dp is equal to 1. Good luck, have fun. Oh, thank you. I got to go. Oh, thanks for stopping by. I appreciate. Times length of nums. Yeah, that should be right. And then for, we iterate left to right, right? So for every I, for every I in range length of nums, so 0 through, every index, you want to check all the indices before it. For j in range I, so 0 through all the way up to but not including I. And what you want to do is if nums j is strictly less than nums I, meaning we can form a subsequence with these two pairs of numbers. We want to track our best solution at this I, right? Maybe I'll do a variable called I best solution. What do I call this? I best solution is equal to negative infinity for now, float negative infinity, and then if the current if we find wait, no, we don't need to do this, right? We can just compare it with the current number 1, like the value 1 in the current DP array. So if we find a pair of numbers that's strictly increasing, we can do nums I is equal to max of the current dpi, the current best solution that we have, and dp of j, but 1 plus that, because we want to include my current number. Yeah. Krishna says hi. Hello. Hi, Krishna. How you doing? Yeah, I feel like that's all we do, right? That's all we need to do. For every I, for every j behind I, if j is strictly less than I, then, oh, this is wrong. The best solution ending at I is equal to the max of the current best solution at I and 1 plus dpj. Meaning best solution at j plus 1. Yeah, this makes sense. Okay. And in the end, we return max of dp. Like the longest length we calculated in the dp array. Run. Oh! Dang, let's go. It worked. This solution is actually kind of pretty. It's so short and nice. Dang. I remember doing this in Java. It took like 50 lines of code or something. It's kind of nice. I like it. Let's see what the fast boys do. What are the fastest solutions here? N is equal to length nums, okay. Temp is equal to num0 for I in range 1 through n. What are they doing? If nums I is greater than temp -1, temp.append nums I. What? Oh, it's a binary solution, huh? Ooh, they're doing another solution. Maybe I check out another person's solution that uses DP. Okay, here. If length of nums is equal to 1, return, oh yes, quick base case. Yeah, if the length of nums is equal to 1, then longest increasing subsequent is obviously 1. n is equal to length of nums. dp is equal to 1 times length of nums. Max length is equal to 0. Okay. For I in range 1 through n, basically all the indices, m is equal to dpi, the current solution, okay? For j in range I, if j is strictly less than nums I, if nums j is strictly less than nums I, m is equal to the max, meaning the current solution. M is equal to the max of the current solution or the best solution ending at index j plus 1, and then you set dpi, the best solution equals to m. Max length is equal to max length, comma, dpi. Oh, I see. Yeah, I guess I figure out the max length as I go. I'm sort of taking the max in at the end. Alright, fair enough. Alright, I think we all figured out which one is better, top or bottom. Clearly it's bottom. Bottom up DP. I don't think you can even solve this problem in Python with recursion, with memoization. I'm not even gonna try. Like, why is recursion framed so expensive in Python? That really sucks, man. Should we preview the next problem? Maximum longest common subsequence. I'm probably not going to do it this stream because it's midnight already for me. I started a bit late too, but we can read this problem. Given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. A common subsequence of two strings is a subsequence that is common to both strings. Oh, okay. Okay, so the example they gave was A, C, E, and then A, B, C, D, E. A, B, C, D, E. Ooh. How the frick? Is this a two-pointer problem? Can we kind of be smart about this and be like, okay, we start our pointers here, and we're like, okay, maybe we put everything into a hash set, like each word has its own hash set, and we're like, okay, this character, A, we've seen A, does the other one contain an A? Sure. Wait, I swear we've tried this technique before and it didn't work last time. Don't remember why though. Do we actually have to do some recursion here? Oh wait, I think I remember this problem. We have to do some sort of recursion function, right? Where we have the two strings, and then we store I and j, where I and j are the indices of the two. Well, yeah, it kind of is a two-pointer problem. Yeah, where I is the pointer of the first string, j is the pointer of the second string. We have two choices. Well, yeah, it's kind of like the use me or don't use me sort of format we've been doing at each recursive call, we have two choices. One, we can either increase the... Actually, we have three choices. We can either increase the index of I, or we can increase j, push it forward. Or if the current characters that the elements are on are equal to each other, we kind of have no choice but to use them, right? Common subsequence. Yeah, we kind of have no choice, right? Yeah, so either advance both pointers at the same time if the characters are the same, or try increasing I, or just try increasing j. Yeah. How do you do this in DP? I have no idea. Probably a 2D array, because we have, in recursion, we're storing two variables too. Would it be... What would the dynamic programming 2D array represent? Best solution starting at... Best solution ending at these indices? Maybe. We can try out next time. I think I'm going to end the stream here. Alright. We solved one horrible DP problem. I call it horrible because I'm bad at it. Longest increasing subsequence. Alright. I'm ending the stream. Thanks everyone for coming. This one's a short one. See ya. I appreciate. See y'all next time.